The universe is a vast and awe-inspiring place, a seemingly infinite expanse that stretches beyond our wildest imaginations. It is a realm where the laws of physics play out on a grand scale, creating a cosmic ballet that has been ongoing for billions of years. It is filled with swirling galaxies, sparkling stars, and mysterious nebulae. These celestial wonders captivate our senses and inspire a sense of wonder and curiosity about the nature of the cosmos. But beneath this beauty lies a history of incredible violence. The universe is not just a serene and tranquil place, it is also a battleground where forces of unimaginable power clash and interact. The universe as we know it was forged in fire and shaped by collisions of unimaginable scale. Imagine stars exploding in supernovae, releasing more energy in a single moment than our sun will emit in its entire lifetime. Galaxies collide and merge, their stars and planets thrown into chaotic orbits. And black holes, the most enigmatic objects in the universe, devour everything in their path, from stars to entire solar systems, warping space and time around them. This is the story of cosmic collisions, a tale of destruction and creation that has been unfolding for billions of years. These events are not random. They are part of the natural order of the universe, driving its evolution and shaping its structure. From the smallest particles to the largest galaxies, everything in the universe is in motion. This constant motion is a fundamental characteristic of the cosmos, leading to interactions and collisions that can have profound consequences. And when things move, they sometimes collide. These collisions can be gentle nudges, where two objects pass close to each other and slightly alter their paths. Or they can be catastrophic crashes, where the energy released is so immense that it can trigger the formation of new stars or even black holes. These collisions can create new stars and planets, seeding the universe with the building blocks of life. The remnants of these collisions can form protoplanetary disks, where new planets begin to take shape. Or they can rip apart entire galaxies, leaving behind a trail of cosmic debris that will eventually coalesce into new structures. The universe is a dynamic place, constantly evolving through these cosmic clashes. Over time, these interactions have led to the formation of the complex and diverse structures we observe today. These collisions, while destructive, are also essential for the universe's evolution. They drive the processes that lead to the formation of new stars, the assembly of galaxies, and the creation of the elements that make up everything we see around us. They drive the formation of stars, the assembly of galaxies, and the creation of the elements that make up everything we see around us. Without these cosmic battles, the universe would be a very different place. The elements forged in the hearts of stars, and during these cataclysmic events, are the building blocks of planets, moons, and even life itself. Every atom in our bodies was once part of a star that lived and died long before our solar system was born. Without these cosmic battles, our own planet and the life it sustains would not exist. We are, in a very real sense, children of the stars, born from the ashes of ancient celestial fires. The story of cosmic collisions begins with the Big Bang, the event that brought our universe into existence. This cataclysmic explosion set the stage for everything we know today, from the smallest particles to the largest galaxies. It was a moment of unimaginable energy and heat, a singularity that expanded rapidly, creating space and time as we understand them. In the first fraction of a second, the universe was an unimaginably hot and dense soup of particles. These particles were in a state of constant motion, colliding and interacting in a high-energy environment. This primordial soup was the birthplace of the fundamental forces and particles that govern our universe today. As the universe expanded and cooled, these particles began to clump together, forming the seeds of galaxies and stars. The cooling process allowed for the formation of atoms, which eventually led to the creation of more complex structures. This period of cooling and clumping was crucial for the development of the universe's large-scale structure. This early universe was a chaotic place filled with collisions between these primordial clumps of matter. These collisions were not random, they were influenced by the gravitational pull of dark matter, which played a significant role in shaping the universe. The interactions between dark matter and regular matter were essential for the formation of the first galaxies. These early collisions were crucial for shaping the large-scale structure of the universe. They created a cosmic web of interconnected galaxies and clusters, each influencing the other through gravitational forces. This web is the backbone of the universe, a framework upon which all cosmic structures are built. They created regions of slightly higher density, which over time attracted more and more matter through gravity. These dense regions acted as cosmic magnets, pulling in gas, dust, and other particles. Over billions of years, these regions grew into the massive galaxies and clusters we observe today. These dense regions eventually evolved into the galaxies and clusters of galaxies we see today. The process was slow and gradual, taking billions of years to unfold, but the end result is the rich and diverse universe we are a part of, filled with countless stars, planets, and other celestial objects. The early universe was a cosmic demolition derby, with particles and energy constantly interacting and colliding. These high-energy interactions were responsible for creating the complex elements and molecules that are the building blocks of life. Without these collisions, the universe would be a much simpler and less interesting place. These collisions were the building blocks of the universe, laying the foundation for the stars, galaxies, and planets that would eventually form. They set the stage for the development of life and the emergence of intelligent beings capable of pondering their origins. The story of the universe is a story of constant change and evolution driven by the forces unleashed in the aftermath of the Big Bang. Stars, the building blocks of galaxies, are not immune to the forces of cosmic collisions. In fact, many stars exist in binary systems where two stars are locked in a gravitational dance around each other. These dances can be elegant waltzes or violent tangos depending on the star's masses and distances. Sometimes these dances end in spectacular explosions. When a massive star runs out of fuel, it collapses under its own gravity, triggering a supernova. These explosions are some of the most powerful events in the universe, outshining entire galaxies for a brief period. Even stars that aren't part of binary systems can collide. In the densely packed environments of globular clusters, stars can pass dangerously close to each other, sometimes resulting in collisions that create even more massive stars or trigger supernova explosions. These stellar collisions, while rare, are a testament to the dynamic and ever-changing nature of the universe. Section 4. Galactic collisions. When galaxies collide, galaxies, vast islands of stars, gas, and dust, are also not immune to the forces of gravity. These colossal structures, each containing billions or even trillions of stars, are bound by the invisible threads of gravity, which dictate their movements and interactions. Despite the vast distances that separate them, galaxies can influence each other through gravitational forces, leading to some of the most spectacular events in the cosmos. Over billions of years, galaxies can be pulled towards each other, resulting in collisions of unimaginable scale. These cosmic dances are slow, taking place over timescales that dwarf human history. As galaxies draw closer, their shapes begin to distort and their stars are flung into new orbits. The gravitational forces at play can even strip galaxies of their outer layers, creating streams of stars and gas that stretch across the universe. These galactic mergers are some of the most dramatic events in the universe, reshaping entire galaxies and triggering bursts of star formation. When galaxies collide, the gas and dust within them can be compressed, igniting a frenzy of starbirth. This process can create thousands of new stars, lighting up the cosmos in a brilliant display. The merging of galaxies also leads to the formation of new structures, such as spiral arms and central bulges, altering the appearance and dynamics of the resulting galaxy. Our own Milky Way galaxy is on a collision course with our nearest galactic neighbor, the Andromeda Galaxy. This impending collision is a reminder that even our cosmic home is not isolated from the grander events of the universe. The Milky Way and Andromeda are currently hurtling towards each other at a speed of about 110 kilometers per second, and their eventual merger will be a defining moment in the history of our galaxy. In about 4 billion years, these two spiral galaxies will begin to merge, creating a cosmic spectacle that will unfold over billions of years. The initial stages of the collision will see the galaxies pass through each other, with their stars and gas clouds interacting in complex ways. Over time, the gravitational forces will pull them back together, leading to a series of collisions and mergers that will eventually result in a single, larger galaxy. This collision will distort the shapes of both galaxies, creating tidal tails of stars and gas, and eventually result in a single, larger elliptical galaxy. These tidal tails are streams of stars and gas that are pulled out from the galaxies during the collision, stretching across vast distances. The final galaxy will be a blend of the Milky Way and Andromeda, with a new structure and composition that reflects the combined history of both galaxies. These galactic mergers, while seemingly destructive, are actually essential for the growth and evolution of galaxies. They play a crucial role in the cosmic cycle, recycling material and triggering new phases of star formation. The collisions can also lead to the formation of new types of galaxies, such as elliptical galaxies, which are thought to be the end products of multiple mergers. They provide the raw material for new generations of stars, and can even awaken dormant supermassive black holes at the centers of galaxies. These black holes, which can have masses millions or even billions of times that of the Sun, can become active during mergers, consuming gas and dust and emitting powerful jets of energy. Thus, galactic collisions are not just destructive events, but also catalysts for creation and transformation in the universe. Section 5. Planetary mayhem caught in the crossfire. When galaxies collide, the stars within them rarely collide directly due to the vast distances between them. However, the planets orbiting those stars are not so lucky. The gravitational forces unleashed during a galactic merger can disrupt the orbits of planets, flinging them out of their star systems or sending them on collision courses with other planets. Imagine a planet, once peacefully orbiting its star, suddenly thrown into the depths of interstellar space, destined to wander the cosmos alone. Or, perhaps even more dramatically, picture two planets colliding in a fiery explosion, their shattered remains forming a ring of debris around their parent star. These planetary casualties are a reminder that even in the vastness of space, no world is truly safe from the forces of cosmic collisions. The universe is a dynamic and ever-changing place, and sometimes even planets can get caught in the crossfire.